Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today, our special guest is Vaughan Woodruff, and he is a sort of a DER czar. So what is a DER, Everybody likes to use these initials and stuff. I know that my grandma was a DAR, a daughter of the American Revolution. Does this have anything to do with like America being independent, Vaughn?
A little bit, but maybe not like the daughters of the American Revolution. And
maybe independent from the grid? Maybe something like that?
From the grid, yeah. Customer-owned things that generate electricity and store electricity for sure.
Yeah, I didn't think you were a daughter of the American Revolution anyway.
I'm a great-great-great-grandson. I'm out here in Maine, kind of one of the foundations of it back in the day.
Oh, that's really cool. I did a class out there that was fun. I like being out there in Maine, except, you know what? They asked me like how long I could teach each day, and I was like, hey, I'm just giving you my per day price. They had me do 2 classes a day, and I was the most burned out I'd ever been. It was like 12 hours of teaching 5 days a week. So after that, I decided not to do that anymore, but I like all those Maine people, and it's nice up there in the Northeast. So it looks like you've done a lot of things. You've been in the industry for a long time, and like me, you also have a class on heat spring. So what is your title that you like to go by? Bro, or do you got something else besides that?
Not bro. You can just call me Vaughn.
I call my daughter bro because she calls all of her girlfriends bro,
Totally. Yeah, no, these days I run a consulting company that's focused on interconnecting solar energy storage, vehicle to grid as it becomes more prominent, but really focus on the regulatory side of it. So you can call me masochist maybe, or sadist. I like to beat my head against bureaucracies.
Well, I'm a little bit closer to San Francisco than you are, so I know some things.
You do. And like you said, in Maine here, we know how to just put our head down and work crazy hours and try and get stuff done at times. So DER, I guess we'll go with distributed energy resources. And maybe you could just give people some examples of distributed energy resources. Yeah, certainly. So for a long time, these weren't necessarily generation devices. They might just be things like demand response, where it's a device that makes load go away when you want it to go away, maybe when there's times of high load on the grid. So like a water heater could be a DER if it's set up.
So if it makes a load go away, does that mean crashing a cement truck into a power pole is a sort of a DER?
If it's an electric truck, maybe. But yeah, these are really about those electrical loads, and DER really has to do with the definition of how something interacts with the electrical grid. The more common DERs that we think about today are things like rooftop solar, commercial or community solar, things that connect at the distribution level versus like big utility scale things that connect to the transmission system. Energy storage, EVs are distributed energy resources, and other technologies. Plug-in solar that we're starting to hear tons and tons and tons about. That would be an example of a DER.
Cool. So where would you draw the line at DER? I know that things are getting bigger, and like a megawatt. How about that? Would a megawatt be a DER?
It would be, and it really has to do with it being connected to the distribution system versus something that's being connected to the transmission system. So 5 megawatts, and for most places it's about 5 megawatts and down would be continued.
So it's more about where you're connecting it. So what if I took a microinverter and then I connected it right on that coal plant, right to the transmission infrastructure? Could that not be a DER then?
Potentially, yeah. If you wanted to go through all that paperwork and pay all those fees to do that.
Just so I could say I did it, yeah.
Just so you say you did it.
I'm going to go check out my coal plant right now, make some plans.
Diablo Canyon, is that still running out your way?
Okay, so we're looking up Diablo Canyon right here, and it looks to me like it's going, and that's over near San Luis Obispo, which is kind of interesting because that's where we have some of the largest PV systems in the world, including that Carrizo Plains PV system that's no longer there, that there was a lot of Arco solar modules that we've been talking about on the podcast over there near San Luis Obispo. So yeah, that's a nuclear power plant, and it's kind of controversial, is it good, is it bad? It's famous for not making greenhouse gases, but it's also famous for, if you wanted to build a bomb, you start off with a nuclear power plant, Or if you had a bomb that wasn't nuclear, you just aim for that nuclear power plant.
And clearly not a DER nor a DAR. So
Yeah, neither one.
neither one.
All right, so let's go away from Diablo Canyon. We're going to put a microinverter on there, make that a not distributed energy resource type of microinverter, just to kind of make a point. So it depends where you put it. Is it on the transmission side or the distribution side? And you might even divide that upon voltages and things like that, like a whole ton of volts. How much is a ton of volts, by the way?
A ton of volts? We measure by various loads out here. I don't know where it would come in there. What is it for you?
Oh, I don't know, thousands and thousands and thousands, probably something
Thousands
like that.
and thousands,
But
yeah.
just you have a power plant, then you have transmission, then you have distribution. And so the distribution is going to be like medium voltage, transmission going to be like high voltage. And so anyway, let's talk a little bit about what you're up to too. So you've got your distributed energy resources that you work with, and you're kind of a specialist in interconnections. In fact, you're making a heat spring class, or do you already have it that has to do with interconnections?
We're developing it as we speak. Yeah,
Tell us some free information from that class,
for sure.
so nobody ever has to sign up.
So nobody has to. Well, the first one's free, so I'll give you all of that. So, yeah, I mean, what we're looking at is that increasingly interconnection is becoming a barrier for projects, especially in markets where there's a lot of solar, and the grid has a finite capacity to host DERs, so generation energy storage, things along those lines, and there's a process there in place that's really formal because it's gate kept by the utilities, and those utilities are regulated by commissions. So as you can see, I'm already talking about a bunch of things that makes people's eyes glaze over. And so really what we're looking to do in this course is a lot of storytelling, because it's really the impact of these processes that get people's attention, right? Like if you're a solar installer, you probably just take for granted, if you're working on a residential rooftop, that you put in an application to the utility and it passes. But there are stories increasingly across the country of even companies that have built a project assuming that it was going to get approved, and then the utility says, well, we got a problem. We're going to have to upgrade the grid to a point where it's going to cost more than the system that you sold to this customer, and so it's probably a no. And companies are figuring out what happens when I'm in that position.
I would almost argue with that there being a limit to how many distributed energy resources you can put there, because if you're balancing them out, if you're balancing out your sources and your loads, it might not even leave the building, or it might have the potential to leave the building. If you looked at your average 200 amp service, on average, it's about 5 amps. So there's a lot that the utility is wanting, and sometimes you'll even see them either adding up the sources and the loads, and they expect the grid to be able to do all that, which is impossible because the sources will take away from the required loads. And then the other way is like just add up all the sources, and if the grid can handle that. Well, people don't turn all the sources on all at once, and when the sun's shining, your air conditioner's on. And we do need to have energy management systems and power control systems that will coordinate all those things like a conductor. But I think with smart grids and things like that, we can put a lot more than those, transmission and distribution lines can handle if we just coordinate them.
Yeah, it needs to be smart, right? Like the grid oftentimes, like when we think about just the most basic of an interconnection process, like what happens. Let's just go with a rooftop solar system. Someone's getting a rooftop solar system, application goes to the utility. Most processes just review that and say, okay, during the worst couple hours of the year, are we going to have any voltage issues or the potential for any voltage issues? And if the answer is maybe or yes, there's a likelihood that that project is going to be told a no by the utility. And as you've noted here, like there's a lot of things, especially as we're in this day and age with power control systems and energy storage, ways to be smarter with the grid. We're dealing with utilities that historically have served us by being conservative and not changing a lot, right? And now things are changing very fast. Utilities don't tend to really innovate and lead on the transition of our grid to being a smart grid unless our regulators do something about it, because they don't have competition. And as regulated monopolies, the method by which we have the ability to exert control or influence is through those public utilities commissions and setting rules so that the utilities follow them.
And I would even contest, are they being conservative? Are they being controlling? Are they being dumb? Because like when we have a source, we are boosting the voltage. When we have a load, we're dropping that voltage down there. So really, by adding all these distributed energy resources, like sources of electricity, which cause the voltage to go up, we're balancing the grid out. We can use less transmission and distribution infrastructure. We shouldn't have to have more. But then you have these utilities and they have their old way of doing things, and they probably just like to be in charge of that grid. And if there's going to be solar going on there that's going to make a lot of money, they want to own it.
I think it's a bit of all that, Sean. Like, for instance, they're responsible for, delivering safe and reliable energy at affordable prices, right? And so if anything goes wrong, it's not going to be a customer who's plugged anything into it that's gotten in trouble. It'll be the utility because they said yes to something they shouldn't. And so I think there's a bit of truth in both of them. So yes, it can increase voltage. A lot of times what we see, though, is a lot of solar isn't necessarily put in just to satisfy load. These aren't off-grid systems where we're sizing them based on the worst time of the year and then storing energy or just dumping energy into things within the home. A lot of these are exporting power to the grid all at the same time. And so, as we see in circuits across the country, you actually see solar doing a great job of driving down demand almost to zero during the day. And so therefore you don't have that load, to balance out necessarily. In some cases, you may see some instances in which there's low load and a lot of solar generation, and that it leads to, voltage issues or issues even at the substation if you've got enough of it.
Mm-hmm. Yep. Yeah, it's kind of interesting. Like, I guess like you have the old style inverters. So you have like the total grid following inverters, where what they do is they just put out as much as they can at all times. But then you have another type of inverter called the grid forming inverter, and it's kind of new, especially in the United States, but it would be more popular in a place like Australia. And it works more like that rotating machinery as far as, keeping that grid going. And then another thing is, like, let's just say that you're in that kind of situation where there's a whole lot of solar on the grid, let's just say there was more than people were using. Well, then what do? You have to curtail some power, turn something off. But it shouldn't be just like you can't build that project. To me, it just seems like, well, for that 5 minutes out of the year or however long out of the year, you just have to turn it off.
Yeah, and I think when I got into the industry, and I had a solar company out here in Maine, and there wasn't a lot of PV out here. And I think early on it was a lot of times it's easy to look at these projects as one at a time. Like, what impact will, this customer's little 5 kW system have on the grid? Mm-hmm. But what we see happening, and this happened in Maine. Maine's got the second highest per capita penetration of DERs in the country. We're a pretty rural state. And a community solar program launched in 2019 in which we saw megawatts and megawatts and megawatts of projects going in, especially in rural areas of the state. And what that ended up doing was, all of a sudden, all of the interconnection rules that we had, when we could think about these projects mostly as one-offs, is the inverter certified, is it going to be installed by an electrician and meet code? All of a sudden there became this issue of, hey, we're starting to see the amount of solar that's on the grid exceed the minimum load that's on the grid. And now it's not just about really those individual projects. As we start to reach these levels of saturation, and places like Maryland and Delaware, New Mexico has experienced this as well, the rules that we had don't really apply anymore. And so it takes, to your point, getting into the nuance a little bit more. And it's not really just for that one project and how it can respond to loads in the house, but how that project, coupled with all of the other projects that are connected to a circuit, are serving the loads. And California's doing some really innovative stuff. I've been involved in some of the work that's being done out there around flexible interconnection and ways to make the utilities innovate. But the reality is the rules around the country aren't even to like a minimum bar yet, let alone able to start innovating like California's doing.
Yeah, and even if you had a 20-year-old inverter, there's a voltage window where it turns off, like anti-islanding, UL 1741. And so if you were 10% above nominal voltage, so let's say you're, residential 240 and you get up to 264, it turns off for 5 minutes. So that would be one way of turning things off, even if it's old technology, is just get that voltage up there. And you don't have to be at 240 volts all the time. Like that's not, you go measure your outlet in the wall, it's not going to be exactly 120. It'll be a little higher, a little bit lower. And it's not going to wreck appliances and things like that too. So they could control the voltage and turn off inverters and things like that, but with the voltage. So there would be other ways to make it happen.
Yeah, and you see modernization of inverters as a result primarily of the levels of penetration that we're seeing of DERs on the grid, right? Like the IEEE 1547 standard, which, the UL 1741 certifies to, that was changed dramatically in 2018. The inverters, it took a while to get inverters that were certified or listed to that standard. But a lot of those have to do with exactly what you're talking about. And the utilities actually don't want those devices to turn off. They may be relying upon them for various grid support. And so, we're seeing states around the country or regions out here, for instance, Maine is part of the ISO New England, so the independent system operator of New England that handles the grid across the New England states. And so they have specific settings that they require to make sure that the inverters behave in a predictable manner when things start to maybe go outside of, outside of the norm.
Yeah, and you could adjust the voltage just by small amounts at a time, and you don't turn off every inverter in the whole block all at once. It would be the farthest one from the transformer probably, or like even if, let's say you had 20 microinverters on a circuit, the one farthest away from the breaker would have the most voltage rise or voltage drop, however you want to look at it. And that one would turn off first, and then it would start working its way towards the breaker. So it's not like you're going to just go, okay, the whole grid's going to go off. It's going to make a big chain reaction and be some kind of famous blackout that people will cite 20 years later. Like we've got some pretty good technology that we can control and I just think we can make the grid better, except we need the policy, which I know you've been working on. And I know we could have the technology, but if we don't have the policy, nobody's going to pay extra for it.
Totally.
Yeah.
Since you were here in Maine, Sean, you realize sometimes we tell these stories that wander a very long way out around the barn to come back to that. And I want to tell a little bit of one of those, which was, about planning, because I was at a conference a number of years ago and someone got on stage talking about like what transportation of the future looks like. And when we think about, and you're in the area, right? Like you got all the Venmos and other vehicles that are rolling around, these autonomous electric cabs
Waymo,
that drive around the city. Yeah. And the guy got up there and said, hey, there's a future that we envision in which, there's these car sharing services that are going on, and there are a bunch of electric vehicles, and they're calculating the minimum amount of miles that need to be traveled, and they're charging at the right times. And it actually helps to take, transportation is a huge cause of emissions in the country. Like it really helps to address that. He goes, there's also a scenario in which like you might live a little bit outside of the city like Sean does, and you drive a big Ford truck that's autonomous into town that's a internal combustion engine. That truck drops Sean off downtown San Francisco and then either drives around town while Sean's working or drives back to Sean's house and then drives back in to pick him up. Or, Sean goes to the grocery store and the truck drops him off and drives around the block until Sean's done with groceries. And his point was like the difference between those two futures is really how we plan. And this comes back to the smart inverters and loads and batteries and how we deal with all of this is it requires planning for us to do it well. There's that scenario in which we use all of these things together in a manner that reduces our need to build out more substations and replace conductors and in a way that really moves us towards clean energy. There's also a scenario in which it's not done well. We do get interruptions in power and it creates chaos. And the difference between chaos and success really it goes right through public utilities commissions and public service commissions to make sure the utilities are doing what we want to see them do in that big plan.
Yep. Great.
You didn't step in any cow manure on that walk around the barn, I hope.
Oh, no, that's good. What was that statistic you told me about Maine being number one? Was it distributed energy resources? Is that
number two? Yeah, we're number two in the country. Hawaii's number one in terms of the amount of DER capacity per person. Maine is number two.
And how is that? That kind of blows my mind. Also, like, how many people are in Maine is kind of...
Yeah, you could walk 3 miles and run into more people from where you live than in Maine. We have like 1.4 million people in Maine. A lot of people, when they think about the East Coast, they think about Boston and New York and Philly and DC. Maine's this rural area that's pretty proximate, right? Like from my house in central Maine, it's like 3 hours to Boston. What that means is that those markets see cheap land up in Maine that can be used to host power, right? So that happens at the non-DER scale at these big utility projects. But then also we opened up a community solar program that was very aggressive. It actually was a pendulum swing far beyond what the industry had proposed, and it attracted a lot of investment around the country to come into Maine and put in these 5 megawatt community solar projects. And so that is the biggest contributor to Maine being number two per capita and the amount of DER capacity in the country.
So it's kind of like your proximity to Boston.
Some of it is that. A big part of it was policy. A big part of it was that the state, after a really contentious gubernatorial administration I used to have to go on talk radio to push back against this governor who would just talk smack about us all the time and really held the industry back. When the new governor came in, she ran on a clean energy platform, and there were a bunch of bills that had just been backed up that passed. And so all of a sudden we went from a pretty moderate market to just explosive growth in that market. And so it really was about policy, and it was about how people were compensated for the energy that was being exported from those solar projects, et cetera, and whether it was attractive enough to make that investment.
Yeah, I got a question for you, just out of curiosity. So there's been a history of SRECs in Massachusetts. So if you're sending some electricity to Massachusetts from one of your projects, does it qualify for that same Massachusetts SREC?
So most of what happens, right, what you're doing is selling the properties of those. And so RECs can sometimes be portable across state lines, depending upon the market they're in. I haven't been dealing with RECs much when I was in the industry, nor at all recently. So I don't know where things stand today. But, a lot of what happens, it's a paper transfer. It's not necessarily about where the electrons flow. It's not like we plug in, a wind farm in northern Maine. Those electrons are going to be the electrons that get delivered to Boston. But it's that real paperwork, these markets that humans create to figure out, okay, if, it's clean energy and the people that are close to it aren't going to pay for it, I could pay for it. And then I get to be able to tout that I'm, generating or using clean energy.
Great. So I see that your main job, I guess it is right now, is you're the principal of Equinox DG. So DG must be distributed generations.
You get it.
And then better than DER.
Better than DER.
And it's named after Equinox. So does that mean you take the solstice off?
No, well, we take the equinox off. Well, it's interesting you asked that. One of the reasons that we branded it as Equinox is, one, I really love the idea, and it still perplexes my mind that there is this time of the year in which everybody on the planet at the same time is experiencing a day that is roughly 12 hours long. It's pretty cool. Also, the other piece of this is that the equinox or equinox is the time of year that we're solving for oftentimes as it relates to the balancing conversation that we're having here. It's really, in lots of markets, it's the spring and the fall when we're not air conditioning a lot or we're not heating a lot. It's kind of in that middle place. It's like San Diego time, right? It's where it's comfortable and you don't need to condition things. That tends to be the hardest thing to solve for because it's low load, and it's also a time when solar tends to be generating a lot of power. And so that's how we came to be.
Yeah, it is interesting, too, that at the spring equinox, there's more sunshine because we're closer to the sun. And so we get like coolness, brightness, and that is a time where you get more solar, so you need to control those things more. I had somebody else too on the podcast, Conti Monroe. You probably know who he is. He's out in the Northeast over kind of not too
Vermont.
far from you probably.
Yeah, he's in Vermont.
And so we'll have a link to that podcast in the show notes, and his company is Connector. So it has the DER in there too.
Oh yeah, I know those guys well.
Yep, and so they have these cool little meter base adapters and stuff like that.
To be clear, no shade. I'm not saying they should have been called Connect DG. We just decided to opt for a different direction.
Yeah, pretty cool. And so what are you looking for as far as with your company, with Equinox DG? Are you looking for customers or?
Right now, I mean, we have some, national nonprofits that we're focused on supporting right now, as well as supporting solar business owners and folks on the front line. In addition, supporting public utilities commissions, their staff, and utilities that are, really looking to solve these problems. A big part of what I'm really focused on, as you can see, this part of my career, I got a lot more weight. I mean, we should have met Sean way back when I used to not have as much weight here. But, I'm really focused on impact at this point. And one of the things is that interconnection, like part of this conversation is a chance to talk about a topic that people don't talk about very much. And it's a problem. There are only a handful of people in this country that understand why these rules exist, let alone why the various requirements within these rules are effective at regulating these processes. And it creates a real problem. Like around the country right now, only 37 states have opted to regulate their utilities for interconnecting these resources to the grid. And in those 37 states, none of them do it exactly the same way. So it's essentially the same process, but it's such a patchwork. And some of these rules are 20 years old. And I think you and I both know there's been a lot that has changed about these technologies in the last 20 years and what kind of projects are being put in now versus 20 years ago. But these are these processes that they're very formal, they take a long time. And if it's not planned for, it can totally thwart the goals that a state has for energy. An example, Delaware, in 2021, they launched a community solar program. And they were so excited about it. They import all of their energy from other states. And this was a chance for them to make some energy in their state in a grand scale. In October of this year, in 2025, one 4-megawatt project had been built. In 4 years, one project had been approved and energized by the utility. And this is because there are rules on the books. Like if you were trying to get one of those projects through and you're like, the utility's taking so long, the rules on the books didn't even have any timeline expectations. For all intents and purposes, the utility was following the rules that were on the books. And unless we update these things, it really can undercut the ability for us to leverage clean energy.
So that you said that was in Delaware?
In Delaware, yeah.
And so that's where Biden's from? Do you think that Biden, it's because he's getting paid off by the oil companies? Just kidding, yeah.
He's been spending too much time in Scranton, I guess.
Yeah.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
Yeah, sometimes I wonder, is it a conspiracy that there's a lot of forces that are against having good, interconnection rules so that it benefits things like fossil fuel companies and stuff like that?
I don't think I will say I have spent a lot of time trying to sort through and figure out how many of these challenges are a result of utilities intentionally doing bad things, how much of them are a result of utilities just are learning something and they have to learn it really quickly, and how much of it is just like us not doing public policy well, us not doing a good job regulating the utilities. And I would say it's been more of the latter two than it has the former. Like at the end of the day, utilities they have their missives, and there's a lot that they can pull at the legislature, but we don't fund our regulators to serve our public interests. I mean, you look at how many lawyers a utility has versus what we have for staffing for these bodies that are expected to regulate these really complicated processes, and it is a challenge. And that's a big part of this effort right now with HeatSpring is like, how do we help crowdsource knowledge about this topic so that we can build up a greater public understanding of this so that we can do a better job of regulating the utilities, but also resourcing our regulators, because having good rules are on the book, just like anywhere else, are only good if they're following them. If there's no one there to enforce them, it becomes ever more problematic. So, there definitely are forces at play, and you will see utilities lobby hard, both at the legislature and at their Public Utilities Commission, to not change things unless it's going to benefit their bottom line. That's built into the DNA of a for-profit investor-owned utility. And there are also all of these processes that we have built that just take a long time and are not responsive to the market in the way that, at the pace that technology changes.
Yeah, I kind of like to think that the people that are behind slowing down solar and the interconnection process are the same people that killed Jack Ruby. And so also I see that you were the VP of Regulatory Reform for IREC. That's the Interstate Renewable Energy Council. And I am an IREC certified master trainer. That's kind of my claim to fame. Yeah.
That's great. Yeah. They do workforce. So that's the side that does the training. They support local governments. And then, the regulatory side. And I've worked a long time with them when I owned a company, just getting their expertise on things. And it was a total pleasure working with that team, because that's a bunch of engineers and lawyers and policy professionals are out doing the really difficult work in the trenches that the solar industry largely doesn't know has built the foundation for a lot of the things that we do day to day.
I've read something somewhere that said that the United States, most of the people running the country are lawyers. And in China, the people running the country are a lot more engineers. Do you think that we should have more engineers running the country? Call me a communist for saying that.
I will say right now, I don't know how much you get into politics, and I try not to get into politics too much, but I remember saying to one of my good friends who's a lawyer in late January of this year that I am not going to make any lawyer jokes for the foreseeable future, because you feel like the difference between a sane society right now and a really, really difficult one that we're fighting up against.
Yeah, and then you're talking about interconnections, and it's really technical stuff. And one of the things that I've noticed about lawyers is a lot of times they think they're an expert on things that they don't understand. So, if like you're talking about like voltage and power factor and reactive power and all these types of things, it's just something that a lawyer probably can't really understand unless they're also an engineer. It's hard enough for an engineer to understand that kind of stuff. So I just think it makes it kind of tricky. And then the lawyers might be looking more at what benefits my client, what benefits the shareholders of this utility, this investor-owned utility, rather than what's going to make this grid work better for a longer time, instead of like, okay, we got this 1 year business cycle or whatever it is, and what's going to get me to the end of that where the stock price goes up.
Yeah, and that's one of the biggest challenges. I will say one of the ways that we were able to find success in Maine is that we had a lot of the folks on the front lines who are able to be parts of the conversation related to some of these technical topics. And that's sometimes happens, but it's pretty rare. That's one of the huge values of IREC, is that they do have lawyers and they do have engineers, and those folks are talking. Because when the utilities come in to have the discussions, the lawyers are not in the room dealing with the back end processes that the engineers are. And sometimes, I've been involved in processes where I need to be in the back room helping those two teams within the same company be able to understand one another. One of the benefits in California you have is Skye Stanfield with Shute Mahali and Weinberger, who's the lead attorney that represents IREC. She is Sean, you should meet her if you haven't met her, because she is the kind of lawyer that is able to talk the talk on the technical side too. And we're very lucky in this country to have her out there because she's helping serve the public interests across the country.
Awesome. So the guy that got me into solar about 30 years ago, his name is Paul Finn. Have you ever heard of him?
I don't know
He's
Paul.
actually in Massachusetts right now is where he lives. He used to live in this exact building with me where I'm sitting here in the Bay Area. And he wrote the CCA law, community choice aggregation. He wrote some green bonds laws and things like that. We'll put some links to, I had him in a couple of podcasts. But he went to school as a philosopher. And then he said, instead of writing books, I'm going to write laws. And he wrote his community choice aggregation law, which was first passed in Massachusetts quite a while ago, probably like 30 years ago, something like that. So maybe instead of attorneys and engineers, we just need philosophers, some more Socrates kind of stuff, you know?
It's funny. My undergrad is in civil engineering. My graduate degree is in education. And I would like to say that the engineering degree has been the bigger asset to me in the solar industry. It has definitely been the education side that has been the asset. Because this gets to a point. I think you were chatting with Aaron last week related to storytelling versus the technical aspects of things, right? And this is a thing I've found throughout time. It's like people connect to ideas and stories and things of the heart versus all the technical stuff that's up in our head that we're, trying to make those rational arguments about. And yeah, it's critical that we have folks who are able to kind of speak outside of the technical space to bring home what the impact is so that we can then drive home those technical solutions.
Yeah, and that was our guest, Aaron Nichols. He's been on a couple of times, and he hates graphs.
He hates graphs. Oh, my word. We're friends on LinkedIn, and he's in everybody's chats. He's probably in their DMs, too, like telling them, here's a meme that's making fun of you for using all this data.
Because I guess kind of like a lot of times if you're just preaching to the choir, what's the use? And so graphs are a lot of times used to preach to the choir. But if you get people emotional, maybe you can get once in a while, you can get somebody to change their tune.
Yeah, and this is the piece that happens within, all these formal proceedings with public utilities commissions. You start dealing with these like very minute technical details. And I think at times people forget, like, this could be the difference between, right, customer A being able to do this thing, right? There was a project that we had in Maine I needed to get into dispute resolution on. There was a guy who he re-roofed the house. So had a company pull down the solar panels, re-roof, and then he decided, you know what? If we're putting stuff back up, let's put up some of the newer and greater. He had like this old Fronius 3,300 watt inverter. He decided to put in a new Solar Edge 5,000 watt inverter that's actually better for the grid. When that application went into the utility said no. And so, like, we're increasing a system by 1,600 watts and putting in a better inverter for the grid, and that doesn't work. Like, it's important that those stories are front of mind because it kind of ties into how ridiculous at times some of these things can be and the need to, like, really dig in and figure out the solutions.
Great. Okay, so I think I'll vote for you to be the leader of Maine or something like that. How close are you to Greenland? Is it?
If I go outside of my house in the morning, Sean, and I look out my deck, I can see Greenland.
All right. I did used to live in Alaska, so yeah.
Yeah. For all you youngins on the pod, that's some shade at Sarah Palin from Alaska. Go Google her or not.
Yeah, she actually was from a Saturday Night Live skit, and she was the vice presidential pick of John McCain, who was not such a bad guy himself, John McCain. I was like, I didn't hate him like I hate some of the politicians.
Yeah. No, that choice tarnished his reputation and opportunity to be in the White House, I think.
Yeah, but it was darn funny, and that was a time when maybe Saturday Night Live got Obama elected, Yeah.
Yeah, but I will not be running for anything in Maine, Sean, so please do not talk to, It doesn't sound like you're on speaking terms probably with the folks who hired you to do the training out here after they ran you through that laborious couple of days of training. So it was probably pretty safe.
I love those guys. They were great.
Who was it?
It was just like, it was Gifford Electric.
Oh, nice.
And they were really cool. They gave me a shirt. I love it. It's one of my favorite shirts.
Sweet. They used to subcontract commercial and community solar projects from the company I worked with.
Yeah, and they're really smart because they got a whole lot out of me. with
That's
my
right.
per day price. That's not going to happen
very
again.
Smart.
But yeah, I remember just like kind of walking around. There's like a river there, and
Oh yeah.
I remember I got
Penobscot.
approached by some Mormon missionaries, and I joined up, and as usual.
Nice.
They were nice to talk to though. But yeah,
Very good.
good seafood. Brought home some lobster. I brought home a live lobster. Yeah.
Right on.
Yeah. So
Is it your pet?
yeah, I don't think I want to tell you what my girlfriend did to it. It was
I have a feeling. I don't know if you know this, but that, lobster used to be what they would feed the prisoners in Maine prisons because nobody else would eat it. And now everybody around the world wants to eat it.
oh really? Those poor prisoners. Yeah.
Yeah.
And now you see people like trying to break the law just so they can get some lobster.
Yeah, to sneak it back to California for
Yeah.
their loved ones.
Lobster rolls. Yeah. Okay. Well, very cool. All right, Vaughn, is there anything else you want to cover today?
I think that's about it. I mean, I think, as we look at the course, a big part of this is twofold. One has to do with strategy, like companies that are in this work. So like the Gifford Electrics of the world, if they were in the process of selling projects, if interconnection isn't part of their business processes, it could result in some pretty challenging circumstances. And so, especially in light of the passing of HR1 or the One Big Beautiful Bill Act, these tax credits, customers rely upon the utility to be eligible for those tax credits, right? And so if an interconnection process, for instance, if that review is delayed, that's going to be highly problematic. If the utility doesn't give permission to operate or needs to build out their system to accommodate that project, and that doesn't happen until after the end of the tax credit, and nobody's dealt with the regulations to deal with it, that's going to be problematic. And companies have an ability to be able to deal with that. So, the coursework that we're building with HeatSpring is one targeted at those folks that make decisions on how processes work within their companies. And then also another course that we're doing is focused on the outward-facing employees that are dealing with customers and dealing with utilities so that they can best understand how to navigate those processes. And not if, but when interconnection challenges arise, like how to best deal with them so that it's not driving everybody crazy, because they have the tendency to do just that.
Yeah, and I kind of wonder too, like with the price of PV going down and people are talking about balcony solar, and at some point maybe people are just going to more and more disconnect from the grid.
Right.
And I've wondered too, like I have just a personal question about this, is what if, like if you have a standalone system, you don't need to have an interconnection agreement. But what if you had a standalone system, but you also had a battery charger where you could charge the battery from the grid, but there was no way that you could, backfeed the grid? Do you need an interconnection agreement?
Typically, yes. Typically, I mean,
That
it
ain't
used to be
fair.
back in the day. Well, I mean, I didn't think so either to start with. And I mean, I don't know, maybe I've become more conditioned over time. But, as the grid operates as a whole, the utilities, when they're balancing things out, are also counting on people's load. So I always used to think, like, if you're going in, let's say, a manufacturing facility, and you put in a project that's a couple hundred kilowatts and never, it's never putting out more than the plant is using, why should the utility care? Well, when the utility is planning, they're planning on the load from that facility. So if you take some of that load off, it does impact other things. And so having visibility to that is important. And because a lot of times those inverters are going to be operating in parallel with the grid, they need to be able to check.
Okay, I have a workaround. I have like a bidirectional EV, like, like a Ford Lightning or something like that.
Yeah.
And then I have a meter that's only for EV charging. And then I take that car and then I plug it into the standalone system of my house on a cloudy day and charge the batteries up with that. Does that require an interconnection agreement?
I mean, the question here is between what can you get away with? I mean, this is about all laws, Sean, and I guess, I'm kind of an ask permission, not beg forgiveness guy. I'm getting a sense of which camp you're in. But a lot of this stuff, I mean, there are folks in California that have probably been illegally putting in projects and writing about them in reports to demonstrate some technologies. I think it really comes down to what the appetite is for the utility to crack down on you and what's on the books. And this is, I think this is the big challenge that we have, right? Like I actually wore it today. Let me see if I can pull it up for you. I don't know if you remember these days, Sean. Let's see. This is what my buddy Chuck Markin had given to me, my Gorilla Solar.
Oh, we have a Gorilla Solar t-shirt there. And that goes back to the home power days where it was pretty much illegal to connect to the grid, backfeed the grid, and that's those days that we had the spinning meters. And Home Power Magazine always had somebody that was covering up their face, feeding the grid. I have a picture of one of those Home Power Magazine articles in one of my slides. That's pretty cool.
Totally, and
that's a valuable shirt there.
It is. My buddy Chuck gave it to me, and I only wear it on special occasions, Sean. But it's interesting, right? Like those days, to your point, with Gorilla Solar, the whole idea was, since we only have a meter reader who's coming around and reading the meter once a month, as long as the meter looks like it's used more energy in any given month, who's going to notice? Things are a lot different these days, right? These meters read at 15-minute intervals. And so, we used to have times I would be sitting in my office back when I ran the company, and Simon, who sat at the front desk, I remember on a couple occasions got a call from the utility, and you could hear the stress in his voice. And I was like, "What's up, Simon?" He's like, "Oh." They called up and they said, "It's pretty interesting. We see this meter that's going backwards out of this place where you interconnection application. You haven't sent us anything to tell us that it's done." And he's like, "Oh shit. The electrician turned it on, commissioned it, and forgot to turn it off." So we would call up the homeowner. But the Gorilla Solar days are a little bit harder now. You could probably do it if you're using that battery and a lot of other things. But I think societally, we want to look at it and say, like, is there a place for us to do this all together, and how do we do it well together? Because there are some of us that have had the good fortune to be in a place to be able to afford solar, to be able to put it in. And there are a bunch of other folks, who are captive customers of the utility and may not have the resources to be able to do it. And so I think that's the biggest question here. And so the regulations have to be good so that it encourages people to actually participate. And I think we run into challenges like you're noting of grid defection, where it's just like, if these things are so Byzantine and, the rules are just going to punish me, then screw it. I'm going to disconnect from the utility, right?
Yeah, and I think, like in my personal opinion, that if you have nothing but a battery charger connecting a standalone PV system to the grid, then that is just 100% load. I don't think you should require an interconnection agreement for that. That's just my own personal opinion. And then on the other hand, let's say that you just have something that has a CT by the meter and it limits the current. That one you kind of are, maybe you could require an interconnection agreement because something could break. Also, you're essentially having something to do with, the power quality and the sine wave and all that kind of stuff. And so I would see maybe an interconnection agreement could be argued there. I still think that you probably shouldn't have to have one, just my own personal opinion.
They're probably not coming after you.
But I could see that argument. Like if somebody just goes out there and gets one of these inverters that they call hybrid or multimodal, and then they have a CT at the meter and make sure it doesn't backfeed, maybe. But just with a plain old battery charger that's charging a battery for a standalone system instead of turning on the generator, I think with that, in that situation, I think that you shouldn't have to have an interconnection agreement. You always need a building permit. Of course, if you're in a cabin in Alaska, 100 miles from the road, you really need a building permit for that, right? It's like
That's right. And if they crack down on you, Sean, you could just cut the cord and just drive your truck to go charge it up and bring home the energy in the battery.
Yeah. Well, good. Well, thanks so much, Vaughan Woodruff, for talking to us on the podcast. And we're going to put links to all these different ways to contact you. And any famous last words and talk about your company or anything?
I don't know what famous last. I feel like I should give you some Mainer thing. Like if the famous saying, I don't know if you got it when you were there, is "Can't get there from here." But I do think we can make this transition. I do think we can get there from here.
Okay.
So see if we can make it happen.
All right. Thank you so much, Vaughan Woodruff, fellow heat spring instructor and the principal at Equinox DG. And thanks for listening to Sean White's Solar and Energy Storage Podcast. Go check out SolarSEAN.com and get yourself NABCEP certified. And then once you're NABCEP certified, you can take our classes to get your continuing education credits and have a lot of fun. It's all about the fun. Ow!